In this video we are looking at indeterminate powers, and the problem is that we need to determine what the limit of f of x to the power of g of x is when x tends towards a. So the indeterminate cases that can exist here is when both of them, the limit of f goes to 0 and the limit of g of x goes to 0. So we have a type 0 to the power of 0. The second case is when the limit of f of x then goes to infinity, the limit of g of x goes to 0, and this is type infinity to the power of 0. The last case is when the limit of f of x goes to 1 and the limit of g of x goes to infinity. So these are called indeterminate powers. Whenever you're asked to determine the limit of two and the other one is a power. So how do we solve this? There's a specific procedure then of solving it. We start off by letting y equal to the to f of x to the power of g of x. In other words, letting y equal to whatever function then we had, like here or here. So you let y equal to this expression. That's what you do initially. And then after you've done that, you don't want to deal with exponents, so we're going to apply a natural log on either side. So we're going to have ln. So when applying a natural log on this side, remember we take that to the bottom, so we'll have gx and then len, and then this len is not len x, it's len f of x, sorry. So this is what we would have. That's what you do initially. Set y equal to that and then apply natural log on both sides. Next, what you do is, now we have g of x times len f of x. This is what we have now. So what we need to do is we need to simplify this. Remember, now we would have been having then products, and what we said on the previous video, when solving indeterminate products, what we want to do is we want to have them written as quotients. So that's what you will try to do again here on this step. And then lastly, what you need to do is you need to determine the limit of g of x times len f of x, right? But remember, you need to determine this limit when this is written as a quotient, so that we have 0 over 0 or infinity over infinity when determining what the limit is. The last thing you do is you apply L'Hopital's rule. Seeing that this is satisfied, you apply L'Hopital's rule and determine the limit of the derivatives. After you've done that, you would have simplified this side then and determined what that limit is using the L'Hopital's rule. So we would have a value essentially on this side. But now we would have solved what the limit of len y is and not the limit of y. So we would remember that in order for us to get y, we would have to apply the e to the e on either side. So we would, to be able to solve for y, we need to have e to the len y. So that's what y is. And then lastly, what you need to do is you need to go and try and, because remember that we would have simplified one side, and then you're going to solve what y is, and then this last step will be thoroughly demonstrated on the next video when I'm doing an example. But this is the general procedure that you use in solving indeterminate powers.